All right, people. I think on the last video, I forgot to mention what makes, or what a little bit of a nomenclature, right? Um, let's just think of like Na, right? Na is an atom. All right, Na plus, that's an ion because it has a charge. All right, and what type of ion is it? Well, this type of ion is called a cation. Pika, where are you? Pika, special guest appearance right now would be the time. We're talking about cations. All right, whatever. She's asleep. Not a cation, a cation. All right, and this happens when you lose electrons because losing a negative makes it positive. All right, and then if you think of something like nitrogen, and then N-3, your nitride. This is called an anion. And the way I always remember these two, well, I used to, is the T is for positive, the N is for negative, right? T looks like a plus, N reminds me of negative. And an anion gains electrons, all right? And the number and the charge depends on how many electrons you gain. If you gain electrons, if you gain 3 electrons, -3. You gain 4 electrons, -4. All right. But anyways, what gains and what loses electrons? Today's section, I believe, we're going over the little bit of the periodic table, and then the types of bonds that are made. Right. So the periodic table right here is ptable.com, best website in the whole wide world. Let's see. We have these portions of the periodic table, and I highly encourage you to get yourself a periodic table, color this up, label it, and yeah, label the sections, but also familiarize yourself so that you don't need it. All right, now the periodic table is separated into groups. Over on the right hand side right here, these are your non-metals, right? Your non-metals. There's also hydrogen over here. We keep hydrogen over here because of some electrons and stuff, and you'll see soon. All right, but the nonmetals are over here, and nonmetals like to gain electrons. For example, everything on this group right here, everything on group 17, the halogens like to gain 1 electron, so they like to get a -1 charge. Everything over here, the chalcogens, they like to gain 2 electrons. So everything here ends up getting a -2 charge. And then, no, I don't even know how to say that. I'm not going to. And you don't have to remember it. But these over here will lose, or will gain 3 electrons. Now, so nonmetals gain electrons, and metals lose electrons. Metals like to lose electrons. So metals, look, there's a lot of metals. All the metals like to lose electrons. Now, some metals are easy to remember the charges. For example, the metals here in group 13 tend to get a +3 charge. Everything on group 2 tends to get a +2 charge. Everything in group 1 tends to get a +1 charge. All right, so the metals like to lose electrons, so they become positive. The nonmetals like to gain electrons. So this kind of allows, or this creates this relationship between the two, where the metal will like to give up electrons, and the nonmetal will like to take those electrons. So if, let's say, you have lithium and chlorine present, lithium metal, chlorine present, they will want to react because the lithium would want to get rid of its electron, and the chlorine would gladly take it, and they create what are called ionic bonds. Ionic bonds are with the metal and a non-metal. All right. Now, we're going to talk a little bit more about them and the nomenclature and stuff, but I want to compare. Now, the molecules, you've heard the term molecule. Molecule refers to 2 non-metals combining together. 2 non-metals. So for example, let's think of H2O, right? H is a nonmetal, O is a nonmetal. Now both of these, they don't, there's no transfer of electrons. There's no positive and there's no negative. There's what you call a sharing of electrons. So nonmetals like to share electrons. So what ends up happening is oxygen, oxygen likes getting 2 electrons, right? Maybe I don't want to talk about it yet. I don't want to talk about this yet. I don't want to confuse you yet. But you should know this. It should be a review. But let's just kind of go with the slide so I don't jump around all over the place because I forgot my place. But anyways, ionic bonds. There's a positive and a negative coming together. All right. Is that it for the chapter? There's no way. There's no way that's such a short. Okay, let's do a little bit of notation. Let's do a little bit, just a tiny little bit of notation. Let's just show what it looks like as like a formula. Let's say like sodium, right? Sodium likes to lose electrons so that it becomes positive, and you write it out like that, right? And then chlorine likes to gain an electron so it becomes this. All right, so look, chlorine will take an electron to make Cl minus. Sodium wants to become an A plus by losing an electron. So that's just a notation that you're going to use to write, and later on we're going to do something with it, but I just want you to get familiar with it. Now the comparisons here, right? So sodium will lose its electron, chlorine will gain that electron, and they'll make a very stable compound called NaCl, sodium chloride. All right. However, on the other hand, I guess, the molecules, I'll use the example from the book where you had CH4, right? Carbon, we're going to talk about dot diagrams later on, but carbon likes to gain 4 electrons, right? If we go back to the periodic table, these like to gain 1, these like to gain 2, these like to gain 3, this one like to gain 4. So carbon wants to gain 4 electrons. And these hydrogens, each hydrogen only has 1 electron. It only has 1 electron. So what ends up happening is they like to share. So these would end up sharing, these would end up sharing, these would end up sharing, these would end up sharing. And now pretend that you have your 2 electrons here for carbon, 2 electrons for carbon, 2 electrons for carbon, 2 for carbon, and it gets its 8. That's called the octet rule, and we're going to focus on that a little bit later. This is just a little brief recap or brief introduction if you've missed out on some stuff. But here's a rough structure of a Lewis structure on this here, okay? But forgive my writing, poor mouse. All right, but this right here, this is called a covalent compound, and it makes a molecule. So whenever you hear the word molecule, you should be thinking non-metal. Whenever you see the word ionic compound, you should be thinking charges. You should be thinking positive. You should be thinking negative. You should also be thinking metal, and you should be thinking non-metal. All right. With covalent compounds, you should be thinking non-metal plus non-metal. I'll put NM plus NM. All right. And you should be able to distinguish this. This is something you should practice. As soon as you see some compound together, you should be like, oh, that's a covalent compound. That's an ionic compound. This should be mastered. All right. Someone's knocking on my door. All right. I've already gone over this, the charges, and then the next video we're going to go over naming certain types of compounds. Okay, we're going to be naming ionic, covalent, ionic, covalent, and we're going to talk a little bit about acids. All right. This should be a review from last year if you had me, or it should be a review from. It should just be a review. But in case you forget, I forget all the time too. Don't worry about it. We're just going to practice it.